Isaac Newton's concept of time, its contribution and limitation. Isaac Newton was a prominent scientist and mathematician who lived in the 17th century. In his landmark work Philosophiae Naturalis Principia Mathematica, often referred to as the Principia, Newton developed the concept of time as an absolute and universal entity that flowed uniformly and independently of any external influence. He believed that time was a property of the universe and was not relative to any observer or reference frame. According to Newton, time was a fundamental aspect of the universe, and he used it as a basis for his laws of motion and universal gravitation. It also had a profound impact on the development of modern physics. Here are some of the practical applications of Newton's concept of time. 1. Engineering design, particularly in fields such as mechanical engineering, aerospace engineering, and civil engineering. These laws are used to calculate the motion and behavior of objects and systems. 2. Astronomy, to make predictions about the motion of celestial objects. Newton's laws of motion and universal gravitation are used to calculate the orbits of planets, stars, and other celestial bodies. 3. Mechanical systems, design and analysis of mechanical systems, such as engines, gears, and machines. These concepts are used to calculate the forces and motions involved in these systems and to optimize their performance. Newton's concept of time as an absolute and universal entity has several limitations. 1. Relativity of time. Einstein's theory of special relativity showed that time was relative, not absolute. This means that the passage of time can vary depending on the observer's relative velocity. In other words, time moves slower for an observer who is moving faster relative to a stationary observer. 2. Non-uniform flow of time. In Newton's view, time flowed uniformly, but this has been challenged by the theory of general relativity, which showed that the flow of time can be affected by the presence of massive objects. In other words, time moves slower in stronger gravitational fields. 3. Time and quantum mechanics. In quantum mechanics, time is treated as an operator, and its evolution is described by a wave function, not as a deterministic flow. Despite these limitations, Newton's concept of time remains a fundamental part of the scientific legacy and continues to be used in many areas of physics and engineering. It has been modified and incorporated into more comprehensive theories. These include Einstein's theory of relativity and the principles of quantum mechanics.